Okay, so let me demonstrate you a collaborative shopping platform application that we have created for the middle year assignment. The project name is Emptum and its backend was created using Spring Boot, which is a polyfunctional microservice infrastructure. And the front end is created using React. The front end and backend is talk with each other via well-defined RESTful APIs. So in order to demonstrate the features, I will first show you the interface, then I will move to the actual implementation. So this is the initial landing page, which is whenever a user come to the system, he or she can see this landing page. And if the user is already registered in the system, he can log into the system in the login section. Either he must register the system. So there are three main actor types, basically admin, buyer and seller is there. So let's say this person is a buyer, in providing corresponding details like this, that person can register with Emptum. Then he or she can enter to the system by providing corresponding details. But as you can see now, if I enter the incorrect password, then it will show the exceptions as well. But if I enter the correct password, then I can simply log into the system. But as you can see, there is no items yet because I haven't add any item as a seller. So first let me log out from this dashboard and let's register as a seller. So let's say this person is a seller and he has these credentials, and let me log in as like this. Okay, so once a seller is logged into the system, he can add item by clicking add item. So there will be a model pop-up displayed over here. Then by providing corresponding details, he can publish his item. So the item is now published. So if I click over here, the details will be displayed. So this is the seller, and if he willing to edit the item, he can do the changes here as well. So the item has been edited as well, and if the item is needs to be removed, by simply clicking remove and delete, then the item will be deleted from the system. So let me log out from the system and let me log in again as a buyer. So now a buyer can see that item which is published by this seller, and if this seller if this buyer click buy button, then the payment gateway will be displayed. So this is a dummy payment gateway, but this can be replaced with actual payment gateway like Stripe or something like that. But for now, in order to demonstrate the system features, we have implemented the demo or dummy payment gateway. So I can simply enter something. So these stuffs are just dummy data, and simply click pay now. Then that item will be paid by this buyer, and it will take some time to complete the payment because there will be a certain amount of communication between microservices. So once that payment is done, that item will be sold, right? Then if you click my item collection, then it will be in the as sold wallet. Okay, so these are the features of the buyer and seller. And let's say if admin wanted to log in with the system, he can provide his details and log into the system. So I think the details are, let me check again. Okay, so this is the admin account that we have created before. So the credentials are in 1, 2, 3. So admin can log in like that, and this will be his dashboard. So once the admin log into the system, he can see the deliveries and as well as the payments. So deliveries is basically a paid item that is need to be delivered to a specific buyer, and payment is relevant payments that are performed by corresponding buyers, and these are the statistics and details that can be seen by admin. Okay, so I forgot to show you that once a buyer is paid for the for that item payment details will be emailed for the corresponding buyer. So if you go to that buyer's email, so this is just my email created for that buyer account. So it will send you a payment slip, which means I buyed a specific item and the payment is 123. Okay, so this is just a dummy data, dummy email, but the payment is real. So this is the payment that I've been claimed when I am purchasing that item, and these emails will be sent by this email microservice, as you can see over here. That email microservice is specifically designed for sending email. Actually, this is the real benefits of having microservices, which means you can independently develop and deploy these microservices that serve some sort of fine-grained requirements. Okay, so I think that's the all about front end and the front end features, and let's move to the backend implementations. Okay, so moving to the backend of the system, this is the backend, and you can see several microservices are there. So user, item, delivery, email, SMS, payment are the main microservices, and Eureka server is there just for the load balancer, just as the load balancer for the local environment. But once we deployed this microservices for the Kubernetes cluster, there won't be necessary of having Eureka server, because K8s handles the load by itself. So if I look into the architecture of the system, basically microservices are specified over here, and the main form file defines all the necessary Maven dependencies. And if I look into a specific microservice, it has its own POM XML as well in order to define its dependencies. So if I move to the internal folder structure for a specific microservice, so for example, let's say if I'm going to the users microservice, then this is the folder structure. So main Java files are controllers, models, payload, repository, REST, and service. And if I move to the controller, so user controller basically define the corresponding APIs, the REST APIs, and this controller will talk to the service layer. So the service layer specifies what is needs to be done internally, and service layer call to the repository, which is the database, and database is implemented using Hibernate ORM. So this database can be replaced by any sort of a database like MySQL, PostgreSQL, or anything like that. And this is the schema for a specific table. So these are considered as models. So this is the schema for the user. And payload has two types, which is request or response. Request is something requested from the server, and response is the response that is invoked by the corresponding microservice. And response will return some sort of object, so it can be user details or user token over here in this specific microservice. And response has a common payload that transfer corresponding object, and it transfers some sort of a message, whether it is successful or whether it is failed or something like that. And there is a type as well to indicate its successful or failed behavior. So this is just for the message passing in between frontend and the backend, or it can be message passing in between internal microservices as well. So how this message passing happen is basically using REST templates. So if I move to the support controller, so the support controller is specifically designed for the microservice communication, and you can see that support server will invoke some sort of functionalities as well. So that is the folder structure of the specific microservice. And moving towards to the deployment, deployment has 3 specific stages. So if you look at the resources, so these application Docker, application Cube, these are the deployment configurations. So initially, when it comes to the development phases, we can simply call this configuration, which is defined in the application.yaml file. And when we are containerizing the specific microservices, it called this application docker.yaml file, and you can see that it called to the specific database as well, that is internally containerized to specific microservices. And when it comes to the Kubernetes deployment, it will call this configuration. So that is the configurations for the deployments. And so as I said before, we have containerized the applications as well. So the front end is containerized like follows, and this run on top of the Nginx web server, and the backend is also containerized, but I haven't run these services because it will cause some sort of performance issues, so otherwise I can't record this video. Therefore I just run those services in the local environment. As you can see over here, if you wanted to run Docker containers, we can simply type docker compose up -d, then those containers will be run. So when it comes to the Kubernetes, we are using Minikube for the local Kubernetes cluster. So all the microservices will be deployed in this specific Minikube. Yeah, so those are the implementation details of the deployment of the backend as well as the frontend. And yeah, that is all about Emptum. Thank you.